This video will cover section 5.4, examples 5, 6, and 7, hopefully. So we're going to start here with talking about amortization schedule. And I'm going to read the paragraph here. So the remaining balance formula is a quick and convenient way to get a reasonable estimate of the remaining balance on a loan. But it is not accurate enough for a bank or business, which must keep its books exactly. To determine the exact remaining balance after each loan payment, financial institutions normally use an amortization schedule, which lists how much of each payment is interest, how much goes to reduce the balance, and how much is still owed after each payment. This is usually created some computer software, but you could also create one using Excel. So we have here a new formula, and here we have capital B, and that is the remaining balance of certain loan. We have here PMT for payment. We know what N is equal to is M times T. And here we have X, which is the number of payments that have already been made. So we go here to this personal loan problem. It says Beth Hill borrows $1,000 for 1 year at 12% annual interest compounded monthly. So find her monthly payment. So first we're going to use the formula for payment. Present value times I divided by 1 minus 1 plus I to the power negative n. And this is a 1 plus. So after substituting here, we have 1,000 for the present value. We have 0.12 over 12 for R over M. And here on the bottom, make sure that when you enter this on the calculator, you use parentheses for numerator and denominator. Then we're going to have here 1 minus parentheses 1 plus, and then again the rate, 12%, compounded monthly, to the power negative. And here we're talking about t equals 1 and m is equal to 12. So because of that, n will equal to 12, 1 times 12. So the exponent here will be a negative 12, and that will give you a payment of $88 with 85 cents. Now for the next part, next question here, we have after making 5 payments, Beth decides to pay off the remaining balance. Approximately how much must she pay? So here, the 5 payments, that's what's gonna take place of our X in the formula that we have here. And so now we're going to use the formula for the remaining balance, which is the payment multiplied by 1 minus 1 plus I to the power negative, and then in parentheses we're going to have n minus x. And this will be divided by I. So now that we know what the payment will be from the previous question, from here, it's 88.85, and that is going to be multiplied by 1 minus 1 plus, the rate that we had was 0.12 divided by 12. And then here for the exponent, this will be n was equal to 12. So if we focus on this part right here, n minus x, that will be 12 minus 5. Or you could just subtract that, 12 minus 5 is 7, and just enter that on the calculator. However, make sure you use that little negative sign, the one below number 3. Then you will have to enclose the numerator and then enclose the denominator, and that will be the rate divided by M and bracket. And the answer for that, for the remaining balance for this account, it will be $597 with 80 cents. For the last part of the question, it says construct an amortization schedule for Beth's loan, and so that it is an example from Excel, and I believe you will need this to answer one of the homework questions from section 5.4. So let's move on to example 6 now. And it says, let us revisit the 30-year fixed mortgage loan described in example 4. The loan amount was this much at a 3.37 annual interest. Each month, an extra amount of money equal to 1/12 of the monthly payment was added to the principal. So the question is, how much quicker is the loan paid off? So first, from example 4, we found that the payments were equal to $1,007 with 35 cents. So we need to figure out what 1/12 of the payment is. And so if we multiply that, we will get 83.95. So if we add the payment plus the extra payment, we will obtain $1,091 with 30 cents. And so with that new type of payment, if we were to look at the amortization table, we will obtain that out of the 360 payments, we're going to have 44 payments less, and so that will be an equal of 316 payments. And so we know that because 44 payments is equivalent to 3 years. And 8 months. So now we just have 316 payments. And this problem is a little trickier. However, we can find this amount by multiplying the payment amount, the $1,091 with 30 cents, times this number. And that will give us $106 with 1 cent. And in fact, I'm just going to stop here for this example. Let's move on to the last one. And for this one, we're going to be using that formula to represent the present value, but the difference here, it will be an annuity due. So that is just like the ones from 5.3, the payment is made at the beginning of each period. And so here we have a problem about the Illinois Lottery Winners Handbook. They discuss the options of how to receive the winnings of $1 million scratch ticket One option is to take 20 annual payments, approximately 50,000, which is 1 million divided into 20 equal payments. The other option is to take a lump sum payment, which is often called the cash value. And if the Illinois Lottery Commission can earn a 4.22% annual interest, how much is the cash value? So what we're going to do is use the payment as 50,000. And we're going to use I as 0.0422 divided by 1 because it is compounded annually. We're talking about 20 annual payments. And we're also going to use n equals to 20 because it is one payment per year, so 1 times 20, 20 years. So from here, to obtain the present value, we need the payment plus the payment. And here we need 1 minus 1 plus I, parentheses, negative n minus 1. All of this divided by I, and we close the bracket. So the substitution for this one will be the payment, which is $50,000, plus the payment again. And then here you will need parentheses for your numerator. Also, well, your denominator will just be 0.0422. And here you will need 1 minus, and then here 1 plus 0.0422. And then in here, the exponent needs to be negative 20 minus 1, so that will be 19. And the present value for that will equal to $694,593 with 49 cents. So the cash value of that price of 20 payments of 50,000 will be 694,593 with 49 cents.